Okay. Hi. Now, I have to say, I've given this talk a couple of times, and looking back, what kind of my most favorite part, and I think the part which really beckons some further discussion, is about this kind of clash of two cultures when doing data science. Basically, on one hand, we have this very engineering approach from people who are coming from a programming background, and on the other hand, you have this kind of more mathematical, statistical approach from people who are effectively statisticians or something like that. And I think this is kind of reflected in a lot of the software that's been made for doing data science, and oftentimes not towards the best results for people actually using it. So, I think the overreaching theme of this talk, and if you don't take anything else from it, take this, is that there shouldn't be such a continuation, that basically doing data science can still effectively be, in other ways, just programming in a sense, or where that we are, and even if you look at just like what's the practice of doing data science is like 80% of the time you're spent just manipulating data. But on the other hand, the tools available, if you look at it from the data science ecosystem, are oftentimes not really well suited to that. Rather, they optimize just for doing the flashy statistical algorithms part, rather than how to actually get data in a sensible form. So, and with this in mind, what I'd like to propose is that oftentimes maybe the data frame abstraction, as you can see in like pandas or R or something like that, it's in fact not the right approach, because in a way it conflates. In one sense, it's an abstraction, and on the other sense, it's kind of a representation as a table. And those two don't kind of necessarily, there's some kind of impedance between both of those interpretations, which sometimes lead to less than optimal expressivity. On the other hand, we have Clojure, which is, rather any Lisp, which is a language which excels in just manipulating data and kind of using the data as a kind of intermediate encoding of the actual computation. So what I see is a very strong point in using Clojure to actually do data science is precisely the part about where you just want to manipulate data or have various intermediate presentations of data, where Clojure is actually very well suited, and it's already kind of, even as is, you don't need some new fancy abstractions like data frames for it to be a very productive system. Now, so in fact, what we want from any kind of environment for doing data science is that easy things should be easy and hard things should be possible. And if you look at the other available tools, what you'll see is that, or libraries, is that you often have kind of a compromise which then leads to one or the other not being all that kind of convenient to do. And this is a big problem, because if you look at like day-to-day when we're doing data science, basically the speed with which we can provide an answer is actually very important. It kind of defines how your company can use data. If you can provide most answers in like 2 minutes or even less, this means that whilst you're brainstorming or they're just discussing some idea, you can pull out the relevant data and look at it. And this completely changes the culture of the company and how it's run. And this is what's powerful. This is what kind of being data-driven should be about. Not waiting 14 days plus for some report which will become completely irrelevant by the time you get it. So actually, think about tools in terms of how they can maximize productivity, and even for the simple task, how they can be actually very convenient and very fast is very important in the larger sense. It doesn't maybe change how you arrive at the results, but the speed it takes you to arrive at the results can have big consequences on the actual effect of your data department. So with this in mind, and to put some of this in practice, I've written a small Clojure library to ease up the most common tasks when working with data. And I'm not really going to spend too much time on it. I just want to emphasize some of the kind of core design principles, which I think kind of tie back to this notion that I really don't want data frames, and how encoding computation in structure is a very powerful notion. So as I said, it's basically no specific specialized data structures are used. It's basically just functions over collections. Here, Clojure's transients help immensely in terms of performance and organizing code. I focus a lot just on composability. So even in terms of DSLs, I try to avoid using macros, because macros aren't as composable as functions can be. And like, I'm a big fan of threading macros, of using a comp of using partial and things like that. And I think that this kind of really enables you to iterate quickly when kind of just trying to combine various bits and pieces to transform your data. Also think that, and this is kind of like the main probably departure from what would be a solid engineering practice in terms of programming, is that I feel that for doing exploratory data analysis, oftentimes it's kind of good for your library or framework to kind of help you in the sense of trying to guess what you do. Like Emacs has become this do what I mean principle, and I think that this has a lot of value when you're talking about live development or just exploratory data analysis. Because like a typical example in Clojure, all the kind of the map filter and so forth are functions which work on seeks, meaning that also the output is going to be a seek rather than retaining the same type. But if you're working with something like sorted maps or something, that's not really ideal. So the Clojure idiomatic approach would obviously be to use into and then choose a collection type. But here, when you just kind of want to do several transformations on your data, it might make more sense to have slightly different functions which actually retain, when possible, the data type you're working on. There's kind of small things which I think you have to think about it, but at the same time, we do have to acknowledge that for me, like the majority of doing data science means doing exploratory work, and there a lot of the kind of conditions and limitations are slightly different than if you're developing an application or a product. Also, I value libraries that require very minimal buy-in. Basically, that you can just pull out one function from it and it improves your workflow, or use the whole thing. And I think it's a kind of solid practice for most libraries, that really you don't have to change your code and really also change your thinking. It should be something that supports you rather than forces a worldview on you. And another thing is, as I said, I'm a big fan of encoding computation in structure, so also it's a library that's kind of is good with just helping you reaching into the structure, deeply nested structures. Right, so, and I want to stay slightly longer on this topic of composability, because really it is the key to doing things fast. Because in a way that this is really then just kind of assembling various, even just mentally just assembling pieces and going together, and it really allows you to have this kind of nice flow when just working with either threading macros or using partial so forth, and just kind of combining things together and not having to think about glue in terms of having anonymous functions or whatever to make the pieces tie together. And this is something that sadly is kind of acknowledging the existence and the beauty of threading macros is not something that's the entire Clojure community has settled on. So sometimes you would have kind of design decisions where the order of arguments is sort of wrong, and you then kind of can't use threading as much. And I think that's kind of a big shame. It's like to the point that even with keyword arguments, something that I've stopped using and rather use just kind of a map of options, which can then be the previous to last argument or whatever, to still kind of retain this ability to use partial and threading. And also, if you really kind of go all in such an approach, it also means that the API is consistent. This is also a strong point of just the core Clojure, where you know that if you have a function that's kind of working on a sequence is going to be the last argument. And that kind of makes a lot of takes a lot of guessing out of how can I use the API when just kind of getting to know it. Yep. And this also, like using composition in a way, I think that, like, if you use it for a long time and kind of start to reflect on just how the code looks, just in a very visual sense, you'll see that it also helps you kind of understand what's going on. And that's one of the things that probably drew me most to Lisp when I started using Lisp, and that was a long time ago. But it's just this kind of visual quality to it, which kind of, you can, just looking at the code, and even if I were to blur all the tokens, you would still kind of have at least a rough idea of kind of what's going on, or how the code and the data flows through your program. And I think that's a very powerful thing, and kind of really helps you when you try to get into another code base, just understand what's going on. And composition is a kind of great way to achieve this relatively standardized structuring, which then kind of implies what's going on. Right now, the other kind of, and this is a big topic throughout this conference, and it's one thing I love about this community is the emphasis on live programming. Obviously, when doing data science, kind of goes hand in hand to do kind of exploratory analysis. So how to approach this rather? There are kind of several things here that are kind of important. One of them is that really when you're doing live programming, you want to be catching errors early. And this is, with Clojure, it's kind of one thing that not ideal in such instances is Clojure's tendency to do nil punning and having various errors, which can then lead to kind of hard to track what's actually gone wrong. Something, you get a stack trace, and then you really have to think about what went wrong to figure out why something doesn't work. So one thing that kind of I try to do with Huri, the data science library I was showing before, is use a lot of spec so that things explode at the point when something went wrong rather than when some expectation breaks. And this greatly simplifies usage, because you try something and you aren't sure of the API, you try it, and if you can get a very meaningful error out, and spec is great for that, it's much easier than just kind of going through these stack traces and figuring out what went wrong. So like before spec, we were using prismatic schema, which kind of works in the same way, but I'm really happy that this is something that's moving into the core of Clojure and also kind of adds a lot of new capabilities that weren't before previous. Actually, one thing that we've now kind of been starting to use spec a lot is to have all our data described in spec, and then this gives you sort of queryable data descriptions. And it's kind of, it's also just in a beginning stages, but what we're trying to build is a kind of system of self-documenting data based on Clojure spec, which you can then also query and do various inference on it. And it seems this is going to be like a great match, which will help immensely with helping new people get on board. Now, but of course, a lot more could be done. Like something that we've seen is the kind of this live evaluation, but the next step I would like to see, and this is just basically a very dumb mock-up, but like if you're using threading a lot, what would be ideal would be to have some way of seeing all the intermediate computations. Again, this is something that would help in terms of just the speed of development and figure out when things went wrong rather than kind of trying to debug this. So I think that there is still kind of, I'm excited for the progress that's been made in live coding, although at the same time I'm also kind of sad that most of it is relegated to Clojure script, while here I'm obviously stuck at Clojure due to library interoperability and just kind of working with plenty of data. But I think that this is something that probably in further future versions of my library I'll be exploring, either kind of expansions to the threading macros, which either give you more information on what's going on or help you optimize things and so forth. But so, as I said, doing data science is fundamentally obviously an interactive thing, and it's also important to kind of think in distributions and kind of see what you're doing and have immediate feedback, not just in terms of that your code is correct, but also like what's going on in a kind of numerical sense, a sense of data. And this kind of also shapes our choices of environment. So what kind of I settled on is using a combination of a notebook, in this case, slightly modified Gorilla REPL, and still Emacs for some other things, mostly because I'm so used to it, and using Gorilla is not really what you would call a very productive environment if you want to write a considerable amount of code. So kind of a combination of both seems to work well, especially since both can reuse kind of the same running instance. But one nice thing, for instance, of using such a notebook is that onboarding new people is amazingly simple. Basically, anyone that comes into my department, they just need to clone one single repo and then just do lane Gorilla, and they have a notebook pops up, and they can kind of start to see and explore and work with code. And this kind of greatly helps with bringing people who haven't used Clojure up to speed. So that's another kind of oftentimes overlooked benefit of using notebooks. And the other, of course, is that if you have a notebook that's written in Clojure, you can then play around with things such as kind of sharing runtime. So here is kind of a very simple example of how we're just kind of modifying the what's being returned. So, and the notebook kind of understands this protocol and then changes what's actually being outputted. So what happens here is that you don't have this kind of separation between, okay, my development environment and my runtime environment, but they kind of fuse together. And this kind of allows you to just build ad hoc tools without even having to think about it. So like one direction, for instance, we've taken this is to start kind of using notebooks also as dashboards. Now, obviously, the moment the notebook is accessible over the internet, it's already kind of halfway there, but then with just a little more effort, you can actually make very decent notebooks with almost no additional work. And it's all Clojure, which just takes what you're working with and then slightly maybe extend how it's being presented. And I think that this kind of a spectrum is something that's quite pervasive in the Lisp culture, or even or Smalltalk culture, but at the same time has huge amounts of potential which aren't yet fully explored. But I don't have any clear idea of where this should go. But it's something that anytime I use it, I'm kind of just smile to myself, thinking, okay, this is really awesome, and it's gonna want to use more of it. So what you would ask, what about the ecosystem? Like Clojure and even Java as such isn't really well known for having loads of machine learning and statistical libraries. And yes, that's a fair point, but it's also relatively irrelevant. Because what you can always do is you can just farm it out to scikit-learn or whatever you want to use, TensorFlow. Like basically, we have a language which excels at kind of being a building block for other languages. So it turns out that it's laughably simple to build a small kind of DSL and transpiler that spits out Python code and just evaluates and just kind of uses Python to do the machine learning task you want to. And as luck would have it, you don't really pay a big penalty because runtime is usually going to be dominated by the algorithms rather than just marshalling data to and from. So that's not a very big problem. Another such example is plotting. Like for plotting, what we're mostly using is actually ggplot, but that's the R for those who aren't really up to speed with those things. It's a very powerful R library for plotting, but we're using from Clojure. So we have a kind of it's a simple DSL, which is actually part of that data science library I was talking about, and which tries to follow all the kind of properties I described previously, and what it does is it generates R code, sends it to the R interpreter, and then you get back an SVG, which can then be shown. And so with very little code, you can have like the most of things that R offers, and kind of very pretty plots with basically this was like one day's work, or even that was just kind of playing with various options and me not knowing ggplot very well. So it's kind of very simple, and you get more than good enough visualizations for most of the tasks. So, and this is kind of a mechanism that can be extended and reused over and over again, just because Clojure is kind of so good at writing small new languages. Right, so let's kind of conclude, and I see I'm kind of slightly running out of time. So to sum it up, like as I said, I think that the main thing is that data science shouldn't be viewed something as kind of as that those other people are doing, but it kind of should be treated much more as a programming problem, as an engineering problem, and this can lead to very concise and powerful and simple solutions to some of the problems that might otherwise plague the practitioners doing data science. And this is especially important because speed of answers matters here. It matters greatly, even more than usually. Obviously, we all want to be done with our tasks quickly, but here actually there is this kind of a massive categorical change if you can provide answers almost real time in terms of how your data is going to use. And this is just going to add massive amounts of value to any kind of data or analytics department. Second thing is kind of we don't really have to reinvent all the wheels in Clojure or just look for Java libraries that we can wrap, but actually we can just generate small snippets of codes of other languages and use those runtimes. And even though it might seem like a super hack, and in a way it is, but it also turns out to be kind of relatively robust and with little kind of rough edges. So it's a very tenable way of approaching problems, especially if you just want to test something out even before you maybe commit to working more with this algorithms and that. It's basically using just scikit-learn or something is more than enough. Clojure is a fantastic language for manipulating structure, and this kind of shines through both in just working with data and generating these small languages. And last but not least, just blurring the line between your working environment, and your problem that you're actually solving is kind of a very powerful idea, which leads you to build more and more specific tools which can kind of help you solve problems. But like, we're very used of writing small throwaway functions which help us solve something, but why not apply the same reasoning also to our development environment? Why not write some small throwaway tools, visualizations, and so forth, which will also help us with kind of solving the task at hand and understanding better. And with this in mind, questions? Up.
Hey, so in the case where it's impossible to do the sort of computations you would like in memory, do you also resort to the kind of maybe compiling Python code to run on Spark or something like this? Or this is not really the kind of work you would like to do with your library?
Well, I try to avoid this when possible. Like, I'm a big proponent of aggressively using materialized views, so you can kind of have pre-aggregated data that you can then work with, but obviously sometimes not possible. Like, concretely, currently where I work, we use Onyx when we want to do some kind of streaming or batch computations that take a longer time, but I haven't found a way which would very kind of naturally connect with the notebook approach to working. Now, I know that the people behind Spark are working on Zeppelin, which is kind of, again, a notebook specifically targeting Spark, which has some interesting ideas. We've also previously, before moving to Onyx, we were using Spark, but I think that if you're kind of fundamentally Clojure-based, Onyx is a much better option. So there's kind of a trade-off. But yes, this situation here is not ideal, but it's also something kind of I try to avoid, because then you have some incidental problems, just the size of your data, which rather than solving the problem at hand. I think it makes much more sense to just kind of try to get the biggest instance you can on Amazon with the most memory and kind of try to solve it this way.
Okay, thanks.
Okay, if there are no other questions, thank you, Simon. And